Hello student, I am Professor Devashish Bose, Head Department of Criminology and Forensic Science, Dr. Hari Singh Gaur Vishwavidyalaya, Sagar, Madhya Pradesh. Today I am going to present a lecture of BSc 5th Sem on the unit Forensic Toxicology Part 4, which has been jointly prepared by myself and Ms. Priyanka Pahade, PhD scholar, a UGC GRF at Department of Criminology and Forensic Science, Dr. Hari Singh Gaur Vishwavidyalaya, Sagar. An overview of extraction methods of poison. Extraction of poison by solvent extraction from various biological matrices. Extraction methods for insecticide poisons from various biological matrices, case studies, and finally will be our conclusion. So, my dear student, today we are going to learn what is extraction and which type of procedure would generally be employed for that. In general, we can also say that it is a method of separation. There are many methods of extraction. The selection of method of extraction depends on different factors like nature of poison, matrix, and also quantity of sample available with us. The analytes of interest should be extracted from sample in minimum step to avoid loss during processing. The extracted material also required proper purification to avoid interference of matrix. The efficiency of extraction and purification determines the lower limit of detection, which is very important, precision, accuracy of the sample. The analyst plays a significant role in the selection of proper methodology on the basis of different parameters like case history, amount of samples, physical state of matrix, analytical requirements available in the toxicological laboratory. So, first we start with the classical methods. Following methods could be classified as classical. Simple distillation. The technique of simple distillation involves heating a sample of liquid into a round bottom flask to convert it into vapors, which is then allowed to flow in another location called condenser, where it is cooled. Condensing is back into a liquid form. In basic distillation technique, there are many modifications which could take place. For example, steam distillation, fractional distillation, distillation under reduced pressure, sweep Co Distillation, etc. Now we talk about steam distillation. In this process, volatile substance which are present is heat sensitive. Matrix can be separated or isolated from blood, urine and viscera by the method of steam distillation. Here, steam is passed by tube from one container where steam is produced into the sample container and the aqueous distillate is collected by condensation. Acidic distillation process includes ethanol, methanol, phenol, hydrogenated hydrocarbons, cyanides, etc. On the other hand, basic distillation process includes basic drugs such as amphetamine, methadone and also aniline, pyridine, nicotine, etc. Now we talk about fractional distillation. This is a type of distillation in which different type of fractionating columns are used to enable separation of a mixture of volatile liquid. So, when we take a mixture of two liquids having a temperature difference of 5 degrees centigrade, then we use this method. Suppose a mixture of ethanol and water may be separated by simple distillation, but if it is a methanol and ethanol, then we can use this type of distillation. Now we come to vacuum distillation. In this type of distillation method, separation of thermally labile volatile compounds, that is all those volatile substances which degenerate on heating, are carried out at low temperature without its decomposition. Now we look into sweep Co Distillation. It is a special type of distillation method in which preferential volatilization of organic compounds, especially pesticide, from oil, lipids or plant extract using a stream of inert gas, and after that isolation of volatile solid absorbents are taken place. Micro diffusion. This is a very easy and popular method. that facilitate extraction of gaseous and volatile matters from biological matrix like blood, urine, stomach wash, and non-biological materials like water, drinks, tea, coffee, which contain trace amount of toxic anions. With this, we come to the modern methods of analysis. So, modern methods of analysis are sensitive, specific, reliable and accurate. They need much less time in comparison to that of classical methods. Following are the modern method of separations. Chromatography. Chromatography is a word or a term originated from Greek word chroma, which means color, and graphy, which means to write. It may be defined as it is a separation technique in which components of substance are separated into individual components according to their affinity with the mobile phase and stationary phase. This technique was first introduced by a Swedish chemist M. Tesvet in the year 1906 when he was separating plant extract. There are different types of chromatographic techniques. Some of them are mentioned here. Paper chromatography, thin layer chromatography, column chromatography. Paper chromatography. This is a separation technique in which active constituents are separated on cellulose paper, which acts as the stationary phase by using a mobile phase like water, methanol, benzene, ether, acetic acid or something else. This is the primitive method of chromatographic use for separation of organic dyes, pigments, inks, cations and anions. This is a method of partition chromatography. Thin layer chromatography. This is an adsorption chromatography. Generally, separation of mixture takes place on a thin layer of adsorbing material such as alumina, silica gel G or cellulose coated on an inert support material such as glass plate, plastic or alumina sheet. Quantitative separation is achieved by this method. This method is also used for the separation of dyes, inks, cation, anions and alkaloid. Now we come to column chromatography. This is an adsorption chromatographic technique. In this technique, a vertical glass tube or a stainless steel tube is filled with an adsorbing substance that acts as the stationary phase. The sample of interest is added onto the top of the column in the form of a solution in a suitable solvent or a mixture of solvents. The system of solvent is then added as a mobile phase, which is to be selected beforehand. Due to gravity and various components are separated. Fractions collected at various intervals will thus contain the different components separated at different intervals. In some cases, the net charge on the column material or sample molecule or both depend on the pH gives rise to greater analytical flexibility. Solid phase extraction or SPE. In older time, the extraction of poison was mainly carried out on solid material like activated charcoal and selective elution by solvents. Nowadays, a method is based on the use of small tubes or cartridges filled with around 100 to 500 mg of an appropriate absorbent, that is siliceous material, and bonded phase that are N-octadecyle, that is C18 or ODS, N-octyl C8, N-hexyl C6, ethyl C2, methyl C1, cyanopropyl, nitrile CN, aminopropyl, amino or APS, etc. have been employed as absorbent with much greater efficiency of separation. Solid phase microextraction SPME. Solid phase microextraction is an extraction technique for organic compounds in aqueous sample in which analytes are absorbed directly from the sample onto the fused silica fiber that is coated with an appropriate stationary phase. When the fiber is inserted in the sample, the analyte portion from the sample matrix enter the stationary phase until equilibrium is attained. The fiber is then inserted into the injection port of a gas chromatography, where it is heated and the analytes are rapidly deabsorbed thermally into the capillary GC column for analysis. Hyphenated techniques HPLC-GC and SFC-GC. The hyphenated techniques, that is HPLC-GC, that is high performance liquid chromatography, gas chromatography, and SFC-GC, supercritical fluid extraction gas chromatography, allows complex samples to be pre-fractionated rapidly according to their molecular weight or chemical classification on a suitable HPLC pre-column or SFC, and appropriate fractions then separated by online capillary GC. The coupling of two techniques has been made by a bypass valve fitted with a sample loop of appropriate volume. Selected fractions are passed to the capillary column via a large retention gap, which utilizes the process of concurrent solvent evaporation to retain the fraction in the retention gap, thus avoiding any preliminary contact with column. This is a very latest technique. Extraction of poison by solvent extraction method after digestion. Due to non-volatile nature of poison, special methods are used for the extraction of these poison. So, solvent extraction method plays a very important role in the extraction of these non-volatile poison from different matrices. It is based on distribution law and immiscible solvents are used for extraction. Distribution coefficient D, C1, C2. C1 is the concentration of analyte in first solvent and C2 is the concentration of analyte in the second solvent. If one of the two liquid contains a solute, this method is found to be more suitable. The system in this case is first shaken and allowed to settle. Some of the solute is transferred to the other solvent. Each of the liquid is a mixture of two immiscible and kind is referred as a phase. Thus, some of the solute is transferred from one phase to another phase. The amount of transfer depends on the relative affinity of the solute from one phase to the another phase. This is relative solubility. The immiscible system may involve two organic solvents. The extraction for the system may be impaired due to the formation of emulsion. Solvent extraction is a common technique in forensic toxicology related to biological matrices. Solvent extraction method has now been upgraded and made automatic using accelerated solvent extraction technique. In case of solids non-biological matrix, continuous extraction by a sock slick may be employed, that is continuous extraction. For neutral and acidic poisons, solvents like ether, chloroform, hexane, carbon tetrachloride are used with a second solvent, which is normally water. After extraction, two layers are formed. One is aqueous layer and another is organic layer, in which we have the acid extract. Take aqueous layer and made it basic by adding a few drops of liquid ammonia. Repeat the extraction process 2 to 3 times. So, we will now have a basic extract. In acidic extract, we will get acidic as well as neutral poison, and in basic extract, we will get basic poisons. Extraction of insecticide from viscera and other biological material. In India, we have heard about farmers committing suicide using insecticide or pesticide because these are easily available in the field, don't need to be purchased from the market as they are readily available with the farmers. For this purpose, we have to pay more attention for extraction of them from biological materials. The extraction of pesticide in biological materials like viscera, stomach content and blood is difficult because of interference from fat, protein and coloring material in the matrix. The extract requires proper cleanup. The extraction in case of non-biological matrix is less cumbersome and requires either minor cleanup or rather no cleanup at all. Method 1. This method is useful for extraction of insecticide from viscera in stomach content. Take 50 gram of minced viscera or stomach wash. To it add 50 ml of anhydrous sodium sulfate and 100 ml of N-hexane. Filter it. Extract it using N-hexane and acetonitrile 50 ml, 25 ml and 25 ml. Mix all the three contents of the acetonitrile. To it add 500 ml of distilled water and 25 ml of sodium sulfate. Extract 3 times by using N-hexane. In condensate, we get the insecticide. Method 2. This method is also useful for extraction of insecticide from viscera, stomach content, etc. The minced viscera or the stomach wash is mixed with equal amount of anhydrous sodium sulfate and acetone. The acetone filtrate extract is filtered. The extract is further extracted twice with 50 ml of acetone. Acetone extract is concentrated to 50 ml by evaporation. The 50 ml of acetone obtained from the above process is taken into a separating funnel and is diluted with around 150 ml of water. Then to it is added 20 ml of saturated solution of sodium sulfate. Extract 3 times by using chloroform while shaking. Combine all the chloroform extract and wash it with water acetone mixture in the ratio of 1:1. Finally, wash it with 50 ml of water. The washed chloroform layer is passed through anhydrous sodium sulfate and evaporates to dryness. Method 3. Extraction of pesticide in stomach wash, urine and vomit. Take around 20 ml of stomach wash or urine or 10 to 20 gram of vomit in a conical flask. To it add 50 ml of N-hexane. Reflex on a water vase for about half an hour. Filtrate it. Mix it with 20 ml of N-hexane in a separating funnel. N-hexane layer is passed through anhydrous sodium sulfate. Filtrate is evaporated to dryness. Method 4. Extraction of pesticide in blood. Take 20 ml of blood sample, add 10 ml of sodium tungstate and 15 ml of N-sulfuric acid. Wash it with 0.9 N-sulfuric acid. Filter the extract by using N-hexane. In extract, we will get the insecticide. Method 5. Isolation of pesticide in non-volatile biological materials. Matrix. Take 20 to 25 gram of solid matrix like rice or other, 100 ml of drinking water or tea or coffee or milk or soft drink, 20 to 25 gram of soil, sand, grains, cereal may be taken as sample. For the above materials, direct solvent extraction is carried out using 50 to 100 ml of diethyl ether without adding ammonium sulfate. The ethereal extract is concentrated by 20 ml and cleaned up by column chromatography as stated above. The diethyl ether extract is collected and evaporated to dryness. This is a case study published by Colonial Service of New Zealand on topic volatile substance abuse, butane based substances. In this case, the disease, a 16-year-old male was found lying face down on the river bank of Black Creek at the end of Fullerton Grove, Willinomata. The cause of the death was found to be butane toxicity, self-ingested but not with the intention of ending the life. The deceased had a history of drug abuse and it was estimated by a friend that in the period immediately prior to his death, he was consuming approximately a can of butane gas every day. Although the court was unable to know the exact chain of event that preceded and led to his death, the disease faculty were undoubtedly adversely affected by the abuse of butane. After huffing butane, the disease collapsed or lost his balance, has fallen forward and remained lying where he fell down. A butane gas can was found lying by his body. It is likely that his collapse or fall was associated with a cardiac arrhythmia event or a reflex cardiac arrest. As assisted by Dr. White, cardiac dysrhythmia leading to cardiac or cardiorespiratory arrest are presumed to cause most death. Comments and recommendation. The coroner commented that based on the number of deaths due to butane toxicity that coroners deal with, clearly inhalation of butane is resulting in death remains a serious problem. The coroner recommended to the Chief Executive of Ministry of Youth Affairs, New Zealand, that the government take a fresh look at supply of or reduction and the policing of volatile substance abuse in light of the evidence contained in these findings. As from 1st July 2011, the Ministry of Youth Development New Zealand was integrated into the newly formed Youth Policy Group under the Deputy Chief Executive, responsible for policing in the Ministry of Social Development. The Youth Policing Group is made up of MYE comprising of funding from youth engagement and regional teams focused on achieving active youth citizenship outcome, a youth justice policy team and a youth employment and education policy team. Given this, and with respect to coroner's recommendation largely falls outside of MYD's responsibility and would be more useful addressed to other agencies. However, the coroner's recommendation is timely. While this young man's death was not found to be suicide, the issue of young people's access to toxic substance is likely to be raised in the current review of the Suicides Prevention Action Plan that is being led by the Ministry of Health. It is also one of the topics currently on the Child and Youth Mortality Review Committee's agenda. The Youth Policy Group, Ministry of Social Development, along with other agencies, is involved with both of the discussion. This young man's death is not simply because of solvent abuse. It raises question about wide issue related to the way we support our young people, how we help them get through tough times and how we make sure that they get the path to a positive future. This is the joint responsibility of the government, and the encouraging thing is that a lot of happening is taking place in this space. So, my aim is that for giving you this story is that just interpret it the farmers of our society. Farmers are committing suicide. So, the government and the NGOs or even we as the responsible citizen could take some step looking at the effort which the New Zealand government had taken. Most of the time, forensic toxicologists receive such type of sample which is composed of lot of substances. So, in this condition, it is quite difficult to identify an individual component or analyte from them. For this reason, extraction methods are used for separation and purification of mixture of compounds. This module is generally focused on the extraction of certain kinds of samples like volatile, non-volatile, solvent extraction methods and methods of extraction of insecticide and pesticide. With all these information, here we come to the end of today's lecture. Do keep in mind what we have discussed today. Now, it's time for you all to do some self-study. This is Professor Devashish Bose signing off. If you want to learn more and enhance your knowledge, you may log on to our website for MCQ, quizzes, LORs at www.cec.nic.in. Till then, thank you and goodbye.